Hi everyone, now let's look at the example 5.6. Steam at 0.2 megapascal 300 degrees Celsius enters a mixing chamber and is mixed with cold water at 20 degrees Celsius 0.2 megapascal to produce 20 kilogram per second of saturated liquid water at 0.2 megapascal. What are the required steam and cold water flow rates? So as always, let's do the given condition first. We can make a sketch for this example problem. We have a mixing chamber, the inlet. We have one inlet. We have another inlet. And we have the outlet. So here, inlet, and outlet. Let's label them as 1, 2, and 3. So at the inlet 1, we have steam. P1 equals 0.2 megapascal. T1 equals 300 degrees Celsius. P2 is 0.2 megapascal as well. T2 equals 20 degrees Celsius. This is the cold water. And for the exit, for the outlet, we know the pressure is the same, still 0.2 megapascal. And the other given condition is the mass flow rate, 20 kilogram per second. And we are looking for the required steam and cold water flow rates, M1 dot and M2 dot, mass flow rates. So let's do a quick analysis. So we have two unknown variables. That means we need two equations. So let's take a look at the equations we just learned above. We have two equations. One is for the mass flow rate, the other one is for the enthalpy. So we will use those two equations. Let's write down the first equation, M1 plus M2 dot equals M3 dot. That's our first equation. And our second equation is M1 dot H1 plus M2 dot H2 equals M3 dot H3. So two variables, and we have two equations. If we can figure out H1, H2, and H3, then we will be able to solve those two equations. So let's see, how can we figure out H1, H2, and H3? Let's say this is equation 1, this is equation 2, and let me start a new page. So we need H1, H2, and H3. So for the inlet 1, which is steam, which is a steam inlet. Let me just put the inlet 1 here so that we will know we are working on the steam at T1 equals 300 degrees Celsius, P1 equals 0.2 megapascal, based on those two given conditions. So since T, P are given, we can use either table A5 or table A6. So let's go to the table. Since we are in table A5, then let's directly look at table A5. 0.2 megapascal, that's 200 kilopascal. 200 kilopascals here. And the saturation temperature is 120 degrees Celsius. Our given condition is 300 degrees Celsius, much higher than the saturation temperature. So from table A5, we know the T1 is much greater than T sat. So we know this is SHB. And then we go to table A6. Let's go to table A6, 0.2 megapascal, 300 degree. 0.2 megapascal, 300 degrees Celsius. It's here. And we got H1 equals 3072.1. So let's write it down here. H1 equals 3072.1 kilojoule per kilogram. And then let's take a look at inlet number 2. Inlet number 2, the given condition is T2 equals 20 degrees Celsius, P2 equals 0.2 megapascal. Yeah, we can go to table A4, 20 degrees Celsius, 0.2 megapascal. 20 degrees Celsius. And we got the P set is only 2.3 kilopascal. And our given condition is 200 kilopascal. So this kind of over compressed. So this is a compressed liquid. So we know this is from table A4. This is Cl, compressed liquid. And in this case, our H2 will equal to HF at this given condition, 20 degrees Celsius. And the table tells us 83.915. Now let's try to figure out outlet 3, the H value. Based on the given condition, it says it's creating saturated liquid SL. So we know this is SL, and P3 equals 0.2 megapascal. Yeah, we probably need to add this given condition to the state 3 as well. SL for state 3. And then now let's go back to the calculation. We will use table A5 since P3 is given. Go to table A5, 200 kilopascal, and that's the saturated liquid. We directly use the HF value, 504.71. Let's write it down. Equals 504.71 kilojoule per kilogram. Now we have we got all the H1, H2, and H3, and we will be able to solve these two equations. So we can do, for example, we can rewrite the equation 1. Rewrite the equation 1 from equation 1. M2 equals M3 minus M1 dot. And then substitute this into equation 2. We will get M1 dot H1 plus M3 dot minus M1 dot. That is M2 dot. We should minus M1 dot times H2 equals M3 dot H3. And in this way, we can calculate M1 equals M3 dot times H3 minus H2 divided by H1 minus H2. Put all the numbers in. So I just skip the calculation. You put all the numbers in, and at the end we will get is 2.82 kilogram per second. And M2 dot equals M3 minus M1. It equals 17.18 kilogram per second. So this is the solution to example 5.6.